Hi class, this is course 2, lesson 24, reducing fractions. Now, we've reduced fractions before, but this time we're going to do a couple extra tricks, I guess, or we're going to reduce fractions in a couple different ways. One way that we can reduce fractions is using prime factorization, and we've done that a little bit just to find the greatest common factor. And what we're going to do now is use prime factorization to simplify this fraction here, 90/324. Sure, you could take a look at this and go, well, they're both even and divide by 2, and then get that quotient and then figure out what that fraction has in common, the factors that are in common, and divide it out again. But there is an easier way, and that is using prime factorization. So first, we need to write 90, our numerator, as prime factors. So let's see, 90, I know that's 9 and 10. And again, when you do prime factorization, what you multiply to get that target number could be anything. 9 and 10 would work, 2 and 45 works. It's all going to come out the same in the end. 9 is 3 and 3, and I know that 3 and 3 are prime, so I circle them. 10 is 2 and 5, and I know that those are both prime also, so I circle them. Now I'm going to do the prime factorization of 324. Okay, now, this one's a little tricky. Let's see, I know my divisibility rules. I know that if the last two digits are divisible by 4, that the entire number is divisible by 4. So I'm going to use 4. And let's see, that would be 4 goes into 32 8 times, and then I would bring down the 4 and it'd be a 1. So now let's see, 4 breaks down into 2 times 2, and again we know that those are prime. 81 is 9 times 9, and we know that those become 3 times 3 and 3 times 3. Okay, so that's prime factorization. But what do we do with that? Well, 90 is 3 times 3 times 2 times 5. So I can write that as 3 times 3 times 2 times 5. That just makes 90. So I can write 90, instead of writing 90 as 90, I can write it as the product of its factors, prime factors. Okay, I'm going to do the same with 324. 2 times 2. 2 times 2 times 3 times 3 times 3 times 3. Okay? So if I multiply that all out, I get the number 324. This is still a fraction. And I am not done because I did not reduce yet. So just like if you would take, if you would start with 90 and divide that by 2, and then take 324 and divide it by 2, I can do that here. See, there's a 2 as a factor right here. I can divide a 2 out there and leave a 1, and divide a 2 out of the denominator and leave a 1. So now I'm going to look for any other pairs that I could do that with. So I see there's a 3 and a 3, so I could divide a 3 out of the numerator and a 3 out of the denominator. And I can do that again, because I have another 3 and another 3. Now, do I have a 5 in the denominator? No. So I have reduced as much as I can, and now I just need to multiply. So I have a 1, a 1, a 1, and a 5, and when I multiply that, I get 5. And when I multiply what's left in the denominator, I get 1 times 2 times 1 times 1 times 3 times 3. So 2 times 3 is 6, times 3 is 18. So the reduction of 90/324 is 5/18. Now, you may be asked after all that to say, well, what was the greatest common factor? And we've done this already, so this should be review. But what number did we divide out of the numerator or the denominator? We don't want to multiply everything that's crossed out together. We just take one set. So it would be 3 times 3 times 2, which equals 9 times 2, 18. Okay. So hopefully you see that we took these numbers here and we put them here. and then multiplied them together. And that's what we really divided 90 by to get 5. Okay, well, another thing that we can do is we can reduce before we multiply fractions. And so we look for a factor in the numerator that we can divide with a factor in the denominator. And there are a whole bunch of ways that we can approach this problem here. But here's what I would do. I know that 5 and 15 are going to divide, they both have a 5 in common, so I'm going to cross out the 5 and divide it by 5. And I'm going to cross out the 15 and I'm going to divide that by 5 as well, leaving me with 3. Okay, now I have an 8 and a 3, and those aren't going to simplify. I have an 8 and a 12, and I have an 8 and a 10, and those are the only combinations that I can use with that 8. 8 and 12 have a 4 in common, so I'm going to divide the 8 by 4 and leave a 2, and 12 by 4 and leave a 3. Okay, now I have a 2. Can I divide a 2 with a 3, a 2 with a 3, or a 2 with a 10? Well, I know that 10 is an even number, so that will divide by 2 as well. So I can divide 10 by 2 and leave 5, and I can divide 2 by 2 and leave 1. So it's okay that you crossed out the 8 and divided it by 4 and left a 2, and then we divide another number by 2. That's perfectly fine. Okay, so now let's see, what do I have left in my numerator? I have a 1, a 1, and a 9, and then in the denominator I have a 3, a 3, and a 5. So I can take this 9, and I know it's divisible by 3, so I'm going to take 9 divided by 3 and leave 3, and I'm going to take this 3. Could I have taken this one? Absolutely, but I just picked this one, not a big deal. Now notice what's left. I still have a 3 in the denominator and a 3 in the numerator. And so I can divide both of those again and leave a 1 and leave a 1. So now multiplying across the numerator, and I know that I'm done because I have 1s all across the top. It may not end up that you end up with 1s. This one just happened to. But the idea is to look to see if you have any common factors remaining from numerator to denominator. And remember, you can go top to bottom, or you can go top to bottom, or you can go top to bottom, but you cannot go perfectly across. You cannot divide numerator and numerator, or denominator and denominator. Okay, so back to this problem. 1 times 1 times 1 is 1, and in the denominator 1 times 1 times 5 is 5. So after we multiply 8 fifteenths times 5 twelfths times 9 tenths, and then simplify, we get 1/5. Multiplying first would create some very large numbers that would be very difficult for us to divide, so it's a lot easier to divide out factors first. Let's try one more problem. I have a 5 here, and I know that I can divide the 5 into either the 10 or the 15. You cannot do both. If I divide 5 by 5 up here and leave 1, I only can cancel that with one of these down here and leave a 2. So then let's take a look. Is there anything else I can do? Well, I know 3. I can divide by 3, and 15 I can divide by 3, and that would leave a 5. And let's see, 12 and 2, that would work. So 12 divided by 2 is 6. And 2 divided by 2 is 1. And let me go back to the black, because 16 and 6 are both even numbers. So I know I can divide those both by 2, leaving me with a 3 and an 8. So now I need to stop and look. I have a 1, a 1, and a 3. I have an 8, a 1, and a 5. Well, I know 3 is not a factor of 8 or 5, so I am done, and I just need to multiply. 1 times 1 times 3 is 3. And my denominator is 8 times 1 times 5, which is 40. There you go. One more example for you. We can factor and reduce before multiplying. Okay? So there are a couple ways to approach this problem. One way, and the way the book will show it, is that we can factor each of these. So we can do prime factorization. I'm going to just work over here. 36 becomes 6 times 6, which is 2 times 3 times 2 times 3. Okay. And 25 is simply 5 times 5. Those are both prime. And 45 is, let's see, 9 times 5, 5's prime, and 3 times 3. And 24 is, well, let's see, 6 times 4, and 6 is 2 times 3, and 4 is 2 times 2. Now we can take all this information over here and rewrite these numbers as products of their prime factors. So 36 becomes 2 times 3 times 2 times 3, and that is, so this was 36, and this is 45. And you don't have to put this here, but I want you to understand where these numbers are coming from. 45 is 3 times 3 times 5, and then this is still times. 25 is 5 times 5, and I'm going to put this over here. And then 24, our denominator in this fraction, was 2 times 3 times 2 times 2, and that was 24. Okay, so now I'm going to change pens, and we're going to start dividing out common factors. And remember, you can go numerator to denominator even if it's in the same fraction. So I'm going to take care of this 3, divide that by 3, and this 3, and divide that by 3, and leave us with a 1. And I'm going to do the same with this 3 and with this 3. Then I'm going to look for diagonal pairs, because this 5 and 5 has nothing in common in its own fraction. So I have a 2 here. I can divide that with this 2 here. And I have another 2 with this 2. And then I'm going to work the other way, and I have a 5 and a 5. Okay, so now I have 1s and 1s over here, so this fraction has just been reduced to 1 with all these other fractions. So what's left over here? Just a whole bunch of 1s times 5. And the denominator is a whole bunch of 1s times a 3 times a 2, which is 6. So 36 45ths times 25 24ths will simplify to 5 6. This is a whole lot easier than trying to multiply 36 times 25 and 45 times 24 and then trying to reduce. So I urge you to try to use some of these strategies. One of the other things you can do with this fraction is, let's see, I'm going to write it down here. And we're going to simplify before we multiply. So we can use those same strategies that we did here with larger numbers. So let's see, you might say, well, 24 and 36 are both divisible by 6. So if I divide 24 by 6, I get 4. And 36 divided by 6 is 6. Oh, but look, these are still both even, right? So I can divide this by 2 and this by 2 and get 3. Now, if I go the other direction, I can divide, let's see, 3 will go into 45, but I think there's a more obvious one here. These numbers both end in 5, so let's divide them both by 5. So 25 divided by 5 is 5, and 45 divided by 5 is 9. So now I'm left with 3, 5, 9, and 2. And I know that 3 and 9 have a factor in common. It's 3, so that will be 1, and this will be 3. So I have a 1, a 5, a 3, and a 2, leaving me with 5, 6, which is what you had up here. Now, no matter what method you use, I urge you to write legibly. Make sure that you can read what you're writing, and that after you cross things out and divide out like factors, you can read what number you have left. It's not uncommon for a number to be lurking here like this 3, and then you miss it. So you do the problem correct, except for you miss or overlook a number. So just be careful with that. Okay, hopefully some of this was a review, and I hope that you learned a few new strategies to help you simplify fractions before you multiply them. So if you have any questions, fill out the note question form, or feel free to ask them in class. See you then.